Welcome to this month's iTWO costX Coffee Break webinar. My name is Tony Shaw and I'm part of the consultant team here at RIB. This webinar forms part of our industry trade series, which so far has covered groundworks, cut and fill, pipework and process equipment and infrastructure amongst other trades. As mentioned on the screen, this video will be covering structural timber framing or structural carpentry. For those of you who don't know, iTWO costX is a fully integrated measuring and estimating solution with universal application, supporting everything from hand-drawn sketches to PDFs, 2D and 3D CAD drawings, as well as BIM files. iTWO costX is available in a variety of feature levels, depending on the size of your business and your estimating requirements. iTWO costX offers quick and easy on-screen measurement that can be live linked to the inbuilt comprehensive workbooks to help save you time and eliminate errors. The platform also offers a professional report writer, an auto revisioning tool to help with updated drawing issues, and much more besides. And as you can see, there are a huge variety of import and export file types supported by iTWO costX to give compatibility with other applications, as we want your processes to be as smooth as possible. Our latest webinar covered the use of iTWO costX to ascertain the quantities of plasterboard interior linings, broken down into the numbers of specific sized sheets, depending on whether they were fixed vertically or horizontally. To view this webinar, you can visit www.ribinternational.com/webinars or visit RIB's YouTube page. This month's webinar is along similar lines, but will focus on structural timber framing or any other members that are placed vertically or horizontally. Jonathan covered many aspects of carpentry measurement in his September 2020 webinar. However, like the interior linings webinar last month, the emphasis this time around is on capturing quantities related to the stock sizes of each member supplied by merchants, in addition to measuring the overall total length. So let's switch over to iTWO costX and get started. So here I have a building open in iTWO costX, which I've already got two drawings, the roof and floor framing plan and the just general roof and floor plans, the layout plans. Both those drawings are loaded in the software, and I already have two dimension groups set up, one for joists and one for studs. So taking the joists as the first example, I've just got one dimension group for 50 by 250 MSG8 joist, which, looking at the schedule at the top here, the legend rather, 250 by 45 or 240 by 45 MSG8 joist are just one of the types used in this building. But for the purpose of today, I'm just going to use the one dimension group. I mean, realistically, it's just a question of copying this dimension group and renaming it to suit the other sizes, and then you can use those for the different types of joists. Contrary to many people's opinion, size doesn't really matter. So although I'm using a small building in this demo, it's the processes or the methodologies I'm going to show you today are scalable to any size of building. It doesn't really matter whether it's a small domestic dwelling like this or a larger commercial dwelling, the principles are just the same. So let's start by looking at the dimension group. If I double click to open the dimension properties, on first inspection it looks like business as usual. We're just going to measure the length and display that length against the dimension group here in the pane at the bottom left. However, if I go to my custom quantities tab on the dimension group properties here, you can see that I've inserted a list of all of the stock lengths of timber in 300 millimeter increments, ranging from 1.8 up to 6 meters. Or if you're in an imperial country, that will be starting at 6 feet, going up in 1 foot increments up to about 18 feet. Anything that's longer than that is bigger than can be supplied in a single length. So I've set up a dimension group, or sorry, a custom quantity called oversize, which we'll see what the effects of that are. So basically here it's just a list of all the stock lengths of timber that the merchants will supply, and I want to enumerate those. For that to happen, I need to go to my measured dimensions tab and set up the various formulas. So here you can see for each of those custom quantities, I've set up a formula to basically allocate, if the length I measure falls into one or fulfills one of these criteria, it will count the dimension group or the dimension into that custom quantity. So what's this formula related to? And it's got the word ceiling in, but that's nothing to do with the ceiling in the dwelling, in the building itself. If I flip back to my PowerPoint presentation, hopefully this little slide will explain the ceiling function in a bit more clarity. So fundamentally, ceiling is a way of saying rounding up, so going up towards the ceiling. So take this length and round it up to the nearest multiple of the figure I've specified here. So in the case of structural timber, we've already seen they're supplied in increments of 300 mil or 1 foot. So if I had a piece of timber such as this, we want to find out what the nearest, or round that quantity up. This is the installed quantity on site. We want to round that up to the nearest increment of 300. So that's what the ceiling function does. It rounds up the length here of 2.2, whatever it might be, rounds it up to the nearest multiple of 300, which in this case would be 2.4. So what that allows us to do is say that we want to, or need to buy a 2.4 metre length of timber, which we'll cut on site, and the cut length will be 2.2 that's installed, and there'll be a small proportion of waste. Okay, going back to iTWO costX. As I say, this basically says, if the length rounded to nearest 300 is 2.4, then count the quantity into this custom quantity of 2.4. If the length rounded to 300 is 3.9, count it as a 3.9. So that's a uniform formula all the way down until we get to the bottom here, where it's basically if the length rounded to nearest 300 is greater than 6 meters, then that is an oversized piece of timber. We can't buy a piece of timber that long, so flag it as an oversized member. How does that look in practice then? So on this drawing, all the joists are drawn individually for me, so I can measure them, but I'll show you in a second how, if they're not drawn, you could still measure them using iTWO costX. So in this case, I'll start at the left hand side, and by pointing at this joist, it's given me a preview that it is 5.173 meters long, the finished timber joist. If I click to measure that, then it's measured one joist. The length, or the cut length, finished length, installed length, however you want to term it, is going to be 5.17 meters. But using those custom quantities, it's telling us that to achieve that, I need to go out and buy a 5.4 meter length of timber and cut it down to 5.17. So very quickly, this one here, if I click on that, that's slightly longer. It goes into the bay here. So for that, finished length will be 5.64. I need to go out and buy a 5.7 meter length. So very quickly, using the line type measurement to pick up those vector lines on the drawing, I can just click across those joists and capture all those lengths. Here it steps from being supported on a steel member to bearing on a wall underneath. So again, clicking on that, we've now jumped up to 5.7 meters long, which will require us to buy a 6 meter length. So again, I can very quickly click across all these remaining joists and measure them all. So the result of that is, given that our dimension group is showing 16 joists, totaling a cut length on site, or an installed length of 90 meters, or just over. But underneath that is giving us a little schedule saying, well, I need to go out and buy 2 5.4 lengths, 7 5.7s, and 7 6 meter lengths. Now, at the moment, it's difficult, well, not so difficult, but I can just hover over them individually and see what lengths they are if I wish. Another aspect I did in the dimension group setup, if we go back in there, on the measured dimensions tab, I've put this great big long formula into the name field. So if we just open up the expression editor, looks quite extensive, but it's just a repetition of the same thing. Basically, it's saying if my custom quantity for 1.8 meter lengths has a value in it, it's greater than 0, then name the dimension as 1.8. If the dimension I'm measuring falls into the 4.2 meter length category, so creates that custom quantity becomes greater than 0, then name the dimension as a 4.20 meters long. So it's just a repetition of that same if statement to actually create a name for each of the dimensions. What does that allow me to do? Well, if I turn the labels tab on, currently it's showing the individual finish length, the 5.76 meters in this case. If I wanted to change that to show the purchase length, the merchant length of 6 meters that I need to buy, what I could do is go to my costX options, and for my drawings we have this option as to what those dimension labels show. So at the moment it's showing quantity and unit, 5.76 meters, but I can change that to being the name. So if I do that and update, obviously with our name having been created based on the supplied length required, it's now showing me that I need a 5.4 meter for that joist. I need to buy 5.7s across this and 6 meters across this range. And if I wanted to, or if I needed to, just zoom the screen accordingly, and I can print that out as a report, either as a PDF or just as the drawing window print. So let's just make sure my screen is landscape to suit the layout I've got here. It is. Let's preview that. There we go. That's a little drawing I could give to someone on site potentially to show them which joists fit where, or which measurements, which lengths they need to pick up off the stack to install these joists. Okay, that's all well and good. Let's just turn the labels off again for now. Now, I mentioned about measuring when you don't have all of the joists measured, or even in this case where they are, I might want to actually shortcut the measurement process. And I can do that by turning on this Rebar Mode. So in this instance, and I'll go to point to demonstrate it as if I was doing this where there is nothing drawn. With the Rebar Mode on, I mean, it's called Rebar, but it's basically designed for anything that is drawn at a set spacing. And with this button on, I have two tasks to do, or two lines to draw, if you like. The first line is the span of the joist. So across here we've got just under 3.5 meters that the joist will be spread across. Each individual joist, and again whether it's drawn or not, I can just click from wall to wall. In this case I'll click from end to end on the joist, and it's showing me there that each one is just under 3.1 meters long. So let's click on that. Having done that, I press the enter key and it gives me this prompt to enter the spacing. So it's telling me the spread is, the span is 3.4 meters. If I tell it that I want to break that up into 450 centers, once I click out of there, it's calculating that there are 9, or will be 9 joists across that span. And because they're drawn for us, we can just verify that. So I've got 1, 2, 3, 4, 5, 6, 7, 8, and one at the end 9. So that's correct. We have this extra distance per bar, designed obviously for putting laps on reinforcing bar, etc. But there's nothing stopping me, if I decide that this joist is drawn up to the wall, but I want it really should bear on the wall, I could add an extra 50mm bearing, say, onto each joist to make it that a little bit longer each time than the 3.1 meters or whatever it was. I won't bother doing that just now. Just update. And if I hover back over this quantity, it's telling me 9 joists. Yes, we saw it calculate that. The total length of those, the installed or cut length on site, will be 27.79 meters. But to achieve that, I need to go out and buy 9 3.3 meter lengths. The length was 3.1. The nearest increment of 300 above that would be 3.3. And there's the spacing at 450 centers. Okay, next thing I notice is I've got these double joists at the end, so that's simple enough. If I just turn off the Rebar Mode, again I'll zoom in a little bit and just find the end of the joist there, and click on there, that's just measured another joist slightly shorter than the others, 2.99, so I can get that from a 3 metre length of timber. And again, the double joist at this end, I can just click from one end to the other and measure that as well. So I've quickly grabbed, I suppose, quicker if I wasn't talking about it, but I've managed to grab all the joists across that distance, but then I've added the extras for the double joists at each end manually, just using straight measurement. Okay, the overall result being that I now have 124 metres of joist to buy, but rather than just knowing that and not knowing what lengths to go get them in, it actually gives me a little schedule there that I need to buy one 3 metre length, 10 3.3s, 2 5.4s, 7 5.7s and 7 6 metre lengths, which again could be useful for an on-site ordering purposes. Okay, moving on to studs, or say vertical members. I'm going to measure those from the general floor layout plans. So let's look at the dimension group here again, just because it is, as I say, the joist was set up for horizontal members. Studs has been set up to measure the length of the wall off the plan, but then gauge the length of the studs vertically that will, I guess, rise up from that plan up from the face of the drawing. So looking at that, if I double click, again the properties are showing that I'm measuring the length off the plan, but in this case I want to display the cut length. Well, where am I getting that from? On my custom quantities, again I have my range of supplied lengths of timber that I can go out and buy, including the oversize if I accidentally measure something bigger than 6 metres. But in addition to that, I have two further custom quantities, one to calculate the number of studs and one to calculate the cut length, which if we go look at that on the measured dimensions, we can see those two formulas there. Now straight away I notice the existence of variables. So there's reference to XVAR spacing, and here we have XVAR top level and XVAR base level. That's telling me that I have variables set up. So just quickly on the variables tab, I have variables set up for this dimension group, yes, to pick up the top level and the base level, being I guess the bottom of the wall and the top of the wall. The difference between those, the top level less the bottom level, will give us the height of the wall. And I've set default value of 2.4 and 0, so basically we have a default value of 2.4 metres, but with this being a variable, you can alter that for each quantity that you take off from the drawing. I also have this variable set up called spacing, which defaults to 600 metres, and obviously I've done that to set up the interval between the members, the studs, across each wall. So again, that can be varied wall to wall if necessary. So back on the measured dimensions, we'll start at the top. Yeah, my wall height is being derived from taking the top level less the base level. The reason for that is for measuring different heights of walls, obviously, but also I've used the base level for the offset. So if I happen to be measuring a wall which commences above floor level, which we will show you the effects of that in a minute, I shall do that, then it's going to use that base level of the wall as an offset to show on the drawing. The standard formula for length by height is going to give me the wall area. I'm not too bothered about that in this instance, but more so I have the number of studs and the cut length quantities which we're deriving here. So again, I've got a formula, round up my length that I've measured from the drawing, divided by the variable called spacing, and add 1. So again, I've probably teaching you to suck eggs potentially, but I have a little PowerPoint to explain that formula. So round up the length divided by the spacing to no decimal places and add 1. So in an instance like this, where we have a wall which is about 3.3 meters long, and in this case we have spacing of 600 millimeters for our studs. Let's look at the first part, or the middle bit of the formula. So the length divided by the variable for spacing. So in our case, the length here is 3.3 meters roughly, The spacing we've got in the variables, the default value is 600 meters, so 600 millimeters, sorry. So if we take 3.3 meters divided by 600 mil, that will give us 5.5 studs required across that spacing. Obviously we don't have half a stud, so if we round that up to 0, that gives us a total of 6 studs, which if we put those onto my little drawing there, 1, 2, 3, 4, 5, 6 gives us the number of studs at the full spacing of 600 millimeters. So if we add 1 to the end on the formula, that gives us the intermediate stud in this case, not quite the full 600 mil, but we need a stud at the end of the wall. So that formula is calculating basically the number of studs in any given length. Back in iTWO costX, having calculated the number of studs across whatever length of wall I measure, and then using the result of that, so take the number of studs multiplied by whatever height the wall is, that will be the length or the cut length of all the timbers that we need. And then using this, the same formulas or similar formulas as before, this time just because it's vertical, they're related to the height rather than the length of the wall. It's basically saying if the height of the wall to the nearest 300 mil is 3.6, then count my number of studs as 3.6 meter lengths. And again, I've got the same formula up here to name the dimensions accordingly. You know, if the value of, in this custom quantity of 2.1 is greater than 0, then name the dimension as a 2.1 meter stud. The only slight difference is, excuse me, here for the 1.8. So I've said if it's less than a 1.8, what I'm actually doing is taking the cut length divided by 1.8, and rather than try and explain that, we'll actually show the effects of that. But basically that is maximising the use of a 1.8 meter length. So if I cancel out of this drawing, this dimension group, because I've got the variables, I'm going to turn on my properties on add. So each time I add a dimension, it's going to pop up the properties, allowing me to set those variable values. And so I can literally just point at a wall. Again, it's giving me the preview that wall is just under 2.4 meters long. When I click on it, it offers me the variables, and let's say for argument's sake that this wall is actually 2.6 meters high from the base level of 0, so yeah, that's 2.6 high, and we'll leave the spacing at 600 mil. When I update that, point back at the quantity, it's given me all those captured values. So yes, I've measured one wall, the length of which is 2.36 meters on plan, the height of which we've just set in the variables as 2.6 meters. Therefore, multiply the length by the height, that gives us a wall area of 6.14 square meters. Using that formula, the old roundup formula there, it's calculated that the number of studs across that length is 5, which sounds about right. You want 1 at 0 at the start of the wall, 600, 1200, 1800, and it would be 2.4, but our length of wall is actually 2.36, so slightly under 2.4. But even so, we'd still need that fifth stud. So that's calculated the number of studs. The cut length is obviously 5 at 2.6 high, but to achieve that we need to actually go out and buy 5 2.7 meter lengths of timber. So that gives you, a whole lot of information just with a single click. Again, this one here, which is slightly longer, click on that. I'll leave the parameters the same, the variables, update. Again, so now this wall just over 2.4 meters, so rather than 5 studs, it's now telling us I need 6, and I can just carry on clicking around all these walls to measure the remainder of them. And what I'm actually going to do is measure this wall across the walk-in robe and ensuite. So starting at left, I'm first off going to measure between the doors, so the full height walls from 0 to up to 2.6 are those 3 sections there. Then by switching to point mode, I'm actually going to click across each of the door openings separately. So this door opening is 630 wide, 631. So I'm going to leave the top level as 2.6, but if I set the base level as 2 meters, by the head of the door is 2 meters high, so our wall goes from above the door head up to the ceiling at 2.6. When I update that, again I've left the spacing the same. It's calculated that again I've got a width across the door there of 630 millimeters. Our height is 600. Offset 2 meters above floor level. The wall area is 0.38. We need 3 studs, but 3 studs at 600 millimeters long totals 1.8 meters, which we would get out of 1.8 meter length of timber. So that's where that slightly different formula came in on the up to 1.8 meter lengths. It's actually maximised that we can get all 3 of those studs from one single cut, or one single supplied length. And same across this door opening here. If I just do the same just to finish it off, again it starts at 2 meters above the floor, goes up to 2.6 with the studs at 600 centres. That again is giving us we can get those 3 studs from 1.8 meter length. How does that look in terms of measurement? Well, if I go to my drawings and turn on drawings menu, turn on my view in 3D, we can see the effects of what I've measured there. So those 2 straight walls that we've measured, and then the 3 sections between the doors and the 2 sections measured above the door, which are offset 2 meters above the ground and run up to the ceiling height. Just like on the previous dimension group, I'm getting all that information. So although it's set to show me that there is 58 meters of wall, the length that I've measured, or all those lengths I've measured, total up to 58 meters. The wall area, the length total up to 9 meters. The wall area is 21.6. It's the cut length that is 58 meters. That's the actual length of studs. So not the length of the walls, it's the length of the studs is 58 meters. However, it's telling me, and again, although I need 27 studs, I only need to buy 23 lengths of timber. 21 at 2.7, the full wall height, and 2 at 1.8, which will create the infills, the vertical studs above the doors. Again, that's basically covered all the vertical members. If I wanted to measure the horizontal ones, well, again, I've got the and break them down into cut length sizes for your horizontal, your head plates, base plates, and the like. Well, I could use a copy of my joist dimension group for that. Okay, rounding this out, as I say, I've got the schedule here or the schedules of the lengths of timber that I need to go out and buy, and the quantities as installed, which will differ if I need to, as well as doing the report, the drawing report, to print a copy of the drawing out. I also have the option to export the dimension groups. I'll just export a summary for now of all dimension groups, which in my case is just 2. That's fine. Put that on my desktop. Okay, and it's set to open automatically, so let's have a look. So on the detailed summary, it's giving me each dimension, so I'm getting my list of all the 2.4s and all the 3 meters, 5.4s, 5.7s, etc. Just listed out. But if I scroll over to the right hand side, it's actually giving me a schedule of all of those totaling up. So 2.7 meter length. So for my, I need to scroll back, the joists, I'm guessing that is. Yeah, for the studs, I need 21 2.7 meter lengths, and for the joists I need 10 2.7 meter lengths. And again, for all of these custom quantities, it's giving me the numbers of each that I require. If I go to the summary, it's just giving me the totals per dimension group. So again, if we just have a look at here, the custom quantities, it's giving me that's the cut length. If we scroll further over to the right hand side, I'm getting my total 2.7 lengths 21 and 3.3 is 10, etc, etc. A schedule of all the different sizes that I need to measure, need to purchase. Okay, that was fairly short and sweet, hopefully. So ideally what we've covered is measuring horizontal and vertical members, but as well as capturing the installed length, which is what is usually done in estimating for pricing, and that's fine for a bill of quantities of many types of estimate. But what we've also got additionally is the merchant sized supply quantities that we need to go and buy from our builders merchants. So for smaller builders and subcontractors doing the carpentry trade, hopefully that is a useful piece of information. All of our webinars are stored at this website that I mentioned earlier. However, if you've got any questions or want to raise any comments or queries, then by all means email us at this address here, support.int@rib-software.com. Thank you for taking the time to listen, and we'll see you again next time.